All right, so we are going to dive right in. First off is I'm a developer advocate, as I mentioned. I like learning technology, and then I like speaking about that or sharing that technology that I've learned in a variety of different ways. A lot of times it's through events like this one, but other times it's tech blogging or most recently podcasting that I've gotten into. So I'm available on lots of different channels. And if you do want to reach out to me after the session is over, we do have just a short time here. Feel free to do that. I'm happy to talk tech, data, Neo4j, and so on. But the all of my contact information will be on the last slide as well. So if you don't catch it here, no worries. I do have hobbies outside of work. Most of those just boil down to the fact that I'm kind of a geek and I like that. So first off, talking about what is a graph. First of all, I get a lot of questions. Is it a visualization tool? Is it a layer on top of another data store that connects things together, kind of like a Spark type of thing? But no, Neo4j is actually a graph database. So it stores the data, but it stores data differently. It's going to store the relationships alongside those entities. This is really, really powerful in querying when you're looking for results that are based on network structure. It's really powerful when it's visualized because you can understand the depth of the network. So, how many hops or how many patterns away you might be. And then it's really powerful when you use these in things like machine learning algorithms and pipelines. So, you're factoring that network into your calculations, things like community detection or page rank and centrality, understanding what is influential or popular in the network. As with most technologies, it is actually much older than, or the foundations of it are much older than the technology itself. It arose from not having a technology that really well solves a specific problem. So as with most things, you come across a scenario, it's like, oh, the technologies we have don't really fit perfectly. I really would love it to do this thing. And so then yeah, out comes a new technology, right? But the graph database had foundations all the way back in the 1700s with Leonard Euler. And it's this story of the seven bridges of Königsberg problem, where there was a math problem in the paper. At the time, you had four land masses in the city of Königsberg, Prussia, at the time, and then you had seven bridges that connected those. And the math problem was, could you start at a point, touch all four of the land masses, cross all of the seven bridges, and come back to the starting point? This problem is actually not solvable in math, but the foundations that Leonard Euler put together to try to solve this problem, you kind of see on the image there on the right-hand side. Your four land masses are represented by the four blue circles, your four blue dots, your nodes, your entities, and then the relationships between those represent the bridges between those land masses. And again, the problem was not solvable in the paper, but that kind of trajectory that he put together to try to solve this problem is what founded graph theory, which is used in lots of other things outside of technology. So let's look at how we construct the data model. This is the property graph data model. There are a few other types of graph data models out there, but property graph is one of the main ones. And we use terms called node and relationship. If you're familiar with the mathematical terminology, it's vertex and edge. But these are the main two components of the graph. Nodes represent objects or entities. So they're kind of your, if you want to think of Java objects or something like that, you absolutely can. But it's kind of your main entities. You can label them, which means you can categorize them or organize them or group them, if you will. You can also add properties. These are metadata. So things like, for instance, the Java version number, when it went GA, so the date that it went GA, a feature title, and so on. Lots of different things can be properties. Then you have relationships, which are the connections between these entities. It shows how they are related, how they are connected. And not only does it show they're connected, it shows you how they are connected. So relationships have to have a type. They have to be stored in a specific direction, although you can read them in either direction with Neo4j. And you can also add properties to these. So for instance, between a Java version and a category, how many features might you have in Java 17 for the lang category, the language category? Well, actually, there are three features that you could sum up and add that to a property if you wanted to. And that just shows properties that are directly related to only the relationship between those two nodes. You can also have multiple relationships between entities. So, for instance, a Java version includes a feature, but a feature might be a new feature for Java in general, and you could denote that with a new relationship. Say a feature was started in or began at a specific version. Labels are kind of like groupings of nodes. I mentioned these when we talked about nodes a second ago. It's kind of like a category. You can also think of it like a domain class. It's not an instance of person, each node is an instance of person, but the label itself is just kind of the outline or the definition of the entire group. And you can also add sub labels, if you will, or multiple labels, where in this case we have kind of lots of persons, but we could also have some of those that they're persons, but they're also employees, and some of those that are also customers. And then we could even have some overlap there. So, say, for instance, at a coffee shop, someone could work at the coffee shop as a barista, but they may also buy coffee from there occasionally too. So, you could add multiple labels to this to represent those different roles. Properties are basically key value pairs. They're associated with a node or a relationship, as we've talked about, and it's kind of like a variable name and value. Again, this is metadata showing kind of details and extra context for each node. Now let's look at modeling. So graph databases are known for being whiteboard friendly. And this basically just means that the model, when you kind of are drawn to the whiteboard and want to sit down and draw out how the different entities you have and the connections or the process between them. You draw that model on the whiteboard typically, or a piece of paper or something, right? And the way that you draw that is actually the way the data gets stored in the database. So, for instance, I took some Java version data, which we'll do in the demo here coming up. And we have Java versions, we have the diff files basically, and then all the changes that were made between Java versions. So the module, the package, the class, the annotations, the fields, the methods, and so on. And I've drawn this out on, in this case, a piece of paper, whiteboard, or something else is fine too. And then when the data actually gets stored, this is what it looks like in the database. So we have the entities themselves, we have the relationships, and you can see it looks a nicer, cleaner version of the model that I drew initially on the piece of paper in this case. So as a Java developer, why would I choose Graph Database? This seems like something new to learn. I've already done a lot of learning, as was talked about in the last session. There's just so much learning. How can I pick and choose? Why would I take another thing on? Well, the first thing is that graphs help you answer data questions, the really complex data questions. So for instance, if you're looking at different Java versions, 8, 11, 17, you want to compare those, you could look at changes between the versions over time. What are my major changes? How many features did they have in the API category that changed over time? Or how did this particular class change from Java 8 to Java 11 to Java 17 to Java 21 now? And later. So you could really compare all those differences because you can see the entire network. You could also get history for one specific feature. So looking at a feature, tracing back through the network, I could understand, okay, was this feature available in Java 8? What did it look like? What did it do? Was it new at the time? How many people were using it? And so on. You can do all this sorts of things with Graph because you can trace that network very easily. It also really well aligns with the Java language in general. Java language is very kind of entity-based with the connections and the relationships defined. This lines up really well with the data structure in the database itself. Rather than having to manipulate or tweak your data model in the application to match what's already in the database, you can align these much better and they sync up very well. So your classes become those entities or objects, represents your domain type. Your variables or your properties are the details for that entity. You have a constructor, which is an instance of that object, and each instance is going to be unique with potentially varying info, right? Some values may be null, some may be different types of values, and so on. So the domain and the actually database domain and the application domain line up very, very well between Graph and Java. You can also retain those relationships. You add a variable as a pointer to another object. It links the entities together. You could add some annotations for mapping, and lots of flexibility and customization here. And again, Java maps really well to this. All right, let's prep for the actual demo portion of it. We are going to build some live code and put together an application and show this in action. But just to kind of give you a little bit of backstory before we get there. So I'm running a Neo4j cloud instance. It's called AuraDB. I'm using a free tier instance. So we have a variety of subscription services for our databases, but there is a free tier out there. It is forever free. So you can load data in and play with it and come back to it in 6 months if you want to. That's fine. And I have loaded some Java language version data. All of the code for that, how to load it, what to use, and so on is available in the repository that I'll show on the last slide too. We're going to use the Neo4j Java driver, which is one of our official drivers, and then the Spring Data Neo4j library. Spring Data Neo4j, so Spring and Neo4j have worked really well together for lots of years. This integration has been around for a long time, so it has definitely improved over time and is really solid to use now. It does include the Java driver dependency, so I don't have to specify that separately. But if you are not a Java and or Spring person, there are lots of other options. We have official drivers as well as very well maintained and excellent community drivers, and then lots of Java frameworks that we also support. So our Spring Data team on the Neo4j side writes a lot of integrations with Java ecosystem frameworks and tools. So there's lots of options available out there, even if you don't particularly want to use the stack that I'm showing today. Spring is going to provide us with the Spring Initializer, which is going to get us up and running pretty quickly with just the outline of a project, basically. It's kind of the skeleton of the project, and then we'll build it up from there. Spring Boot reduces a lot of the boilerplate code that you might have to write otherwise. It uses annotations for object graph mapping. So if you're familiar with object relational mappers, ORMs with relational databases, this is basically the same thing just for graph databases. And it's going to map to your plain old Java objects, your POJOs. You can also use query derivation and domain-specific language, DSL, for custom queries, which in our case, Neo4j uses the Cypher query language. So that's what we could write. And I will show an example of that if I have time. And then Spring Data just really easily connects to Neo4j. There are lots of Spring Data projects out there that connect to different databases, Neo4j just being one of them, and it does provide easy connection with the Spring Data project. Okay, let's actually dive into this and code something. So I'm going to switch over to, if it will flip for me. 1 second. There we go. Okay. So I can flip to the application, but then sometimes it doesn't pull up the tab that I want or the window that I want. Okay. So we're just going to stick with Maven, Java, the stable version of Spring Boot for right now. So we can leave all these. I'm going to organize the project into a specific group for me. And then I'm just going to call this Extreme J demo, and we'll stick with jar packaging. Java 17 is the kind of default for right now. And then we want the web dependency, which is going to allow us to create a REST API so that we can query the endpoints. And then Neo4j, the Spring Data Neo4j. There are AI capabilities, a Spring AI project available. We're just not going to use that today. So we're going to use these two, and we're going to download, again, just the skeleton project. This is just going to create our POM with the dependencies in it and our main class. So now I'm going to switch and open that project up. 1 second. And so this will need to switch. And IntelliJ had some really nice upgrades recently with some of their like coding aids. And those are pretty nice, but sometimes they get it wrong. So I will probably have to fix a couple of things that they try to like drop in there for me. Okay, so I usually just check the POM to make sure we got everything stable, current version of Spring Boot, and then our Spring Data Neo4j dependency, which includes the Java driver, and then the web dependency for our REST API. Okay, so now we can actually start coding. And normally you would set up database credentials to connect to the database instance. I have done that already using environment variables. So I ran a script in my command line and it already took care of that to connect to the database. So I don't have to show you the username and password and so on for my database instance. But, and also it's good practice to put those environment variables or put those outside of the application, those credentials. So that's the way I've done that in case anybody is curious. Okay, let's first start off with defining our domain. So I had kind of mentioned, and I meant to show the data model of this, but we are going to pull Java versions and then the features that they have released for those Java versions, and then the category of those features. So whether they're API, language, and so on features. So the first thing we're going to start with is a Java version entity. And I'm just going to create records. If you're not familiar with those are just kind of condensed versions of classes. You don't have to do the whole getter, setter, constructor. So we're just going to stick with that just for short demo that we have today. So first thing is I need to specify the ID, which I did with the annotation. The other thing is that the actual property in the database doesn't quite match what I want to use, so it just calls it version. But if you're familiar with Java at all, there is actually a keyword that is called version. And so I didn't want to overload that, so I called it Java version here. But then I have to map that property to the database property called version. So just so you know. So we have a string name. We have, if you're familiar, some of the earlier Java versions had code names. Then we have a status, so whether it's currently GA or end of life. And then we have a couple of dates we want to track. So first of all being when it went GA, when it went live for public use, and then the local date for the end of life date. So when it went end of life and kind of shut down support. Okay, with that, let's go ahead and charge on to our next one, which is the feature. And how am I doing on time? I've only got a couple more minutes. Okay, so we're going to do ID, string, and this is just title here, the feature title. Now I need to combine these two. So I need to go back to my Java version. I need to create the relationship here. So I'm going to use the at relationship, and the Java version includes specific features. And so we're going to have multiple features potentially, right? Because hopefully every Java version releases more than one feature. And so we're just going to call this features. Okay, so that's the relationship. Now I need to define a repository interface. We're going to call this Java version repository, and we're going to extend, it always wants to do that, the Neo4j repository. Java version, yes, but the ID is not a long type, it's a string type. So I have to fix that. And then I'm just going to clean that up. Okay. Last but not least, we could write in our controller. So Java version controller like that. And we need to annotate it as a REST controller so that Spring will do a couple of things for us there. And then we need to inject our repository so that we could use queries or methods we've defined in our repository interface. So I need to inject the Java version repository, and we're just going to call this repository. And then it's complaining because it wants me to write a constructor. There we go. It generated it for me. And then we can add the first rendition here. So we're going to expect a list of Java versions, get all is fine, and repository.findAll. So Spring provides a few kind of standard methods out of the box. So find by ID, find all, delete by ID, save, so on. If you need custom implementations of those, you can absolutely write those. But if you notice back in the repository, we didn't define any methods because for this one, we're just going to use the available out of the box method for now. And then I'll show you an example of actually doing a custom method as well. So I'm going to switch over to terminal here, and I'm going to go into Extreme.js demo, and let me size this up a bit. There we go. Maven Spring Boot. If I could type, run. So this will run the app. And it might take a second to spin up. And then we will call that. Okay, that's looking good so far. So I can use the HTTP tool, which is just a flavor of curl, if you will. It's just a nice, has a couple of nice features on top of curl. So HTTP/8080, because port 8080 is the default for Spring Boot apps. And you can see we get our Java versions back. So this is coming back from our graph database. You can see we have the Java version, and then we have the titles of the features that are involved there. So in Java 22, you had string templates, foreign function and memory API, unnamed variables and patterns, and so on. Now, I'll quickly show, pause that for a second, and then quickly show how we can write a custom query. So in the Java version repository, I'm going to put an @query annotation, and this is standard across a lot of Spring Data projects. So if you're working with Spring Data Mongo, Spring Data JPA, or so on, you can do this. It will just, your query syntax will change based on the database you're working with. So I'm going to write cipher. So this is, we're going to look for Java versions, match Java version. We have a relationship called includes that goes to features. And then we're going to return the Java version. And then we're going to collect the related entities into lists here, just to ensure you don't get duplicates. And then I want to limit to 2. Yeah. Because maybe we want to scale that down a little bit. 24, because the Java 24 is currently in development. So we don't really want 24 releases of Java and all the related features and so on. So we could scale that back just a little bit. And I'm not going to call this, yeah, we can do that. I'm not going to call this find all. I'm going to find Java version subset. That way it's a little bit shorter, or a little bit more specific, not shorter. Okay, so now let's create a new endpoint. I'm going to call this subset. And then we're still going to get Java versions back. We're going to return the repository dot find Java version subset that we just defined here. So do that. Now, if I go back to my terminal window, I rerun the app, and then we should be able to go to that /subset endpoint, and it only returned 2 Java versions for us. And again, we could write some pretty fancy queries as long as we can map those back to our entities. And there's lots of other things too available. I have more like projections and kind of scaled down versions of classes and stuff defined in the repository I'll show at the end. So /subset. And you'll see, okay, we get Java 1.2, picked one of the early versions, and then Java 1.1. So we could tweak that to pick some of the later versions or something too. But you can see we only get 2 now in the request and not all 24. Okay, so with that, I think we're pretty much out of time. I'll jump back to slides just to showcase kind of resources and where you can find stuff. And then we will hand it back over. First of all, we do have an online developer conference this Thursday, Neo4j does. So if you're interested in graph databases, whether you're completely new to them or want to kind of go deep on some things, there's lots of content available. You can see kind of the 4 tracks that are out there for building applications or just learning graphs in general, or kind of data science things, knowledge graphs, and so on. I do have a presentation that day as well. And if you can't get on that day, everything will be recorded. So if you go ahead and register, you'll get access to all those recordings afterward as soon as they're available. Okay, last but not least, all of the resources. So code for everything we talked about today. And then that includes how to load the data set into a Neo4j instance, how to spin up a cloud instance, and so on. If you want to know more about Spring Data Neo4j, the documentation's there at the second link. Again, our online cloud instance, if you want to spin one of those up and just play with it, they have kind of preloaded data sets you can drop in and some sample queries and kind of walkthrough guides. So feel free to check that out. And then again, that link for our upcoming conference this Thursday with all the related graph goodies. Feel free to check that out. And my contact information if you think of something after the event. Thank you so much for watching, and I hope you enjoy the rest of Extreme J.